Good morning everyone, and welcome to today's worked exam answer video. Now, I loved what we did yesterday with the two different multiple choice questions on the same sort of theme, so I've gone for a repeat of that layout / structure today, where I'm focusing on redox, and the second question is, in my opinion, one of the trickiest sort of redox style questions we can have, because we're thinking about oxidizing and reducing agents. We're also thinking about whether that means something has gained or lost electrons, or rather here, all the options are gains electrons, and I think that's a really tricky question in that there's quite a lot to get your head around, and I know that I personally still, when I'm thinking about oxidizing and reducing agents, have to come back to the definitions, and hopefully I'll be able to show you perhaps not the best way, but a good way of approaching that sort of question. But I didn't want to dive straight in with that, so I thought we'd start with question number 1. So we have to identify which of these is a redox reaction. Now, to be a redox reaction, hopefully we are happy with the fact that we need to have both oxidation and reduction occurring, first of all. Now, there are 4 different definitions for both of those words, which involve either gain of oxygen or loss of oxygen, gain of hydrogen, loss of hydrogen, loss of electrons, gain of electrons, which is what we're going to need down here a little bit. And then the final one, which was new to A level, is the increase in oxidation state being oxidation and the decrease in oxidation state being reduction. And if we have a look at the equations here, I'm pretty sure that the easiest way to do this is going to be with oxidation states. So to be a redox reaction, we would be looking for an oxidation state for an element that increases to represent oxidation, and an element whose oxidation state decreases to represent reduction. Now, that could be the same atom or a different atom, so long as we've got products whereby the oxidation state has gone up and in something else that's formed, a different species, it's gone down. Now, you might be thinking, oh my god, that's such a lot of work for 1 mark, and I agree. If we were to kind of just go straight in and tackle the very first question, it perhaps would then be, the very first equation, it perhaps would be that would feel very laborious. But what I can suggest is, in these types of questions, if you have elements present, as in just as elements, not part of a compound, in any of the equations, I would definitely recommend that we start there. Why? Because the oxidation states of elements, when they are just elements on their own, is 0. So the magnesium and the sulfur on the reactant side of that bottom reaction will have oxidation states of 0. Now, when we put these elements together into a compound, the overall oxidation state on the compound will need to be 0, but these will be ions with charges and oxidation states. So magnesium, being in group 2, will have an oxidation state of +2, and sulfur will therefore, in this instance, be -2. Sulfur is one that has variable oxidation states, but here it needs to be -2 because the Mg can only be +2, and overall that compound needs to have an oxidation state of 0. So hopefully we can then see that the magnesium has shown an increase in oxidation state, so that's what's undergone oxidation, and the sulfur's gone from 0 to -2, and that is a decrease in oxidation state, so that is reduction, and therefore we have redox occurring in that reaction, and that's our answer. So you may have looked at that question and as soon as I said oxidation states thought, okay, yeah, I can work through and add all the oxidation states to all of those equations, and that's great, absolutely brilliant. But in terms of thinking about time saving, that, you know, that's going to take probably at least a good minute or two, and you may not have that amount of time come the summer. So if there are ways that we can speed things up, then yeah, let's try and do that. So elements, because they have oxidation states of 0, if the element on the other side then appears in a compound, which I presume it will in all cases, or as an ion that then has a charge, then that's the one that I would focus on first. Now, just to give you a sense of why one of these other options is wrong, if we were to go for the just the one above, just at random out of the 3, and I did the same thing and I went through and wrote out the oxidation states, sodium being in group 1 is +1, bromine in this case therefore would need to be -1 because the sodium's +1, and in the compound we would need the overall oxidation state to be 0. H2SO4, a bit more complicated because we've got 2 knowns and 1 unknown, but if each hydrogen is +1, each oxygen is -2, -8 plus 2 is -6, so the sulfur needs to be +6. Same thing on this side for the NaHSO4 oxygen, each of them -2, sodium in group 1 needs to be +1, hydrogen +1, -2 times 4 is -8, +2, -6, sulfur is still +6, H +1, therefore Br -1. So no change in oxidation state. That is actually one of the reactions that we need for the group 7 chemistry, whereby we've got sodium bromide reacting with sulfuric acid in what in this instance is an acid-base reaction. Yes, the bromide ions can reduce the sulfur, but they are not doing that in this equation here. And if we did the exact same thing for B and A, we'd arrive at the same outcome. Now, one little thing, I wrote +1 under the hydrogen even though there was 2 of them, and -2 under the oxygen even though there was 4 of them. Had I have not done that, it might have looked like the hydrogen had gone from +2, which would be the cumulative for both H's, might have looked like the hydrogen had gone from +2 to +1, and therefore that might give you a wrong indication of redox when redox isn't happening. So I would always write out the individual oxidation states, not the cumulative. Okay, so that's the first question. Now we're going to need a little bit of that in the second question as well, which is why I thought it'd be good to proceed with that one. So in this question, which statement about this redox reaction is correct? And before I even look at any of the options, because it's told me that it's a redox equation, first thing I'm going to do is exactly what we've just done with the oxidation states. So tin as an ion with a charge of 2+, oxidation state +2. Cr2O72-, each of the oxygens -2, 7 lots of -2 is -14, and we're trying to get -14 to -2. So I'm going to have to +12, and then there's 2 chromiums, so each chromium would be +6. 2 H pluses, H is +1. Then on the right hand side in our products we've got chromium 3+ ions, so +3. SnO2, and if each oxygen is -2, 2 -2s are -4, so tin here is going to be +4, and then -2 for the oxygen and +1 for each hydrogen in our water. Now from there you can hopefully already see that we've got changes in the oxidation states. So looking at the chromium has gone from +6 down to +3, so that is a decrease in the oxidation state, so the chromium has been reduced, whereas the tin has gone from +2 to +4. Increase in oxidation state represents oxidation. Okay, now I'm going to have a look at the options. So we've got to decide whether the tin is an oxidizing or reducing agent, and if it's either of those, whether it gains electrons, or the other two options are the dichromate ions, Cr2O72-. Are they an oxidizing or reducing agent? And in either case, do they gain electrons? So the other version of the definitions we're going to need here is our oil rig. So oxidation is loss, reduction is gain. Now, it's not necessarily easy to see in a redox equation whether something is losing or gaining electrons, and that's why I think the oxidation states are easier to do that with, because we can see +2 to +4, increase in oxidation state, therefore oxidation. And as soon as we know it's oxidation, we then know what's happening in terms of electrons, because oxidation is loss. So the tin will lose electrons. And the chromium that's being reduced, reduction is gain, chromium will be gaining electrons. And if you have the half equations before the redox equation, then that makes life a little bit easier, because you can look where the electrons are in the half equation. If they're on the left hand side, they're being gained, and if they're on the right hand side, they're being lost. But we don't have the half equations because they gave us the overall redox, so we're going to have to use oxidation states to then help us to think about electrons. So the Cr2O72- is definitely gaining electrons because that is being reduced. The chromium within that is being reduced. The tin is losing electrons, so immediately, because of that, it's not gaining electrons. We can get rid of A and B as possible answers. So we know the chromium is gaining electrons, so that's fine. What we now need to think about is it an oxidizing or a reducing agent? So again, coming back to our definitions, we want to be thinking about an oxidizing agent will oxidize something else, and in the process is itself reduced. And conversely, a reducing agent will reduce another species in the reaction and will itself be oxidized. So what did we say was happening to the chromium? It's decreased its oxidation state, which is reduction. So if it is itself reduced, it has to be the oxidizing agent. So it's not going to be a reducing agent. It's clearly going to be an oxidizing agent. And that gives us our answer C. So there's an awful lot going on there again for 1 mark, and whilst we might be able to hold some of that in mind, and I'm not suggesting that you write out everything that I've written out, one thing I would be doing is thinking about changes to the oxidation states. And again, I probably didn't need to do that for every element. Chromium is a transition metal. Transition metals have variable oxidation states, so that might have been a good place to start with the chromium. It's very rare that hydrogen and oxygen are anything other than kind of +1 and -2 respectively when in compounds. So then tin was the other one that I probably would have gone to, and then I might not have needed to write it like this here, but for me, if I'm holding too much in my head, I just end up needing to go through it all again and again and again just to check I've not made a mistake. So actually it's quicker to just write a few things down. Obviously it doesn't need to be nice and neat because there's no method marks, and again, not saying you need to write out the definitions, but that's just to show you my thought process and how I arrived at the answer. Okay, so whatever works for you is obviously best, but hopefully that's helped you to see how to get to the answer for question number 2. Once again, guys, thank you so much for watching, and I really hope that this has been useful to some of you. And if anyone's got any questions or any requests for videos, please don't hesitate to get in touch. Hope you have a really good rest of your day, guys. Thank you.